So now, moving into section 3.4, we're going to talk about more details about the shape of a graph. We're going to talk about what we call concavity and points of inflection. Because we know when we're going up and when we're going down, but there's a little bit more to the shape of a graph than that. We say that our graph is concave up if its little part takes on the shape of an upright parabola. And I can say that a graph is concave down if it looks kind of like an upside down parabola. And for this graph that I gave you, I think we're initially concave down, which includes a part where we're increasing, then another part where we're decreasing. And then we are concave up. That point where we change from one to the other has a special name, and we call that a point of inflection. It is a point of inflection, and make sure when you write that you include an L in inflection, otherwise it means something else. Concave up looks like an upright parabola, concave down looks like an upside down parabola. Take a moment, get that copied down. To figure out these things, let me give you the actual definition of concave up and concave down, because it looks like an upright parabola and it looks like an upside down parabola isn't super mathematical. I've got a curve over here, looks like I'm concave down over there, looks like I'm concave up over there. I'm going to graph some slopes of this thing. Slope over there, slope there, slope there, slope there, slope is 0, slope there, and there, and there, and there, and there, and there, and slope is 0. A function is concave up if, think I'm concave up from about here over to there. Look at what's happening with the slopes. I've got a negative slope, and I've got a slightly more, let me see. I've got a negative slope, maybe -1. This slope is negative but not quite as steep. Negative but not quite as steep, negative but not quite as steep, negative but not quite as steep, 0. Small positive, bigger positive, bigger positive, bigger positive, bigger positive. My slopes themselves are increasing. I'm concave up if f prime is increasing. Similarly, f is concave down if f prime is positive slope, little less positive slope, little less, 0, small negative, small, bigger negative, bigger negative, bigger negative. If f prime is decreasing, if our slopes are decreasing, we are concave down. That's our actual definition. Take a moment, get that copied down. To actually deal with this, though, here's our little test we're going to use. Concavity. We're going to say that f is concave up. Where f prime is increasing. But we already saw in the last section, anything is increasing where its derivative is positive. So I need the derivative of f prime to be positive. And the derivative of f prime is f double prime. I'm concave up where my second derivative is positive. Similarly, f is concave down where the second derivative is negative, where f prime itself is decreasing. So where the derivative of f prime is negative, which means our second derivative. Concave up where the first derivative is positive, concave down where, no, sorry, I said that wrong. Concave up where the second derivative is positive. I still think I said that wrong. Wow. I need a nap, I think. Concave up where f double prime is positive, concave down where f double prime is negative. Points of inflection. These occur at places where our second derivative is either 0 or undefined. So I'm going to say if f double prime of c equals 0 or f double prime of c equals undefined, kind of like our critical value idea, but those are only related to the first derivative. This will be our second derivative equivalent. And I'm going to say that f has a point of inflection at x equals c if my second derivative, f double prime, changes sign there. If my function's changing from concave up to concave down or concave down to concave up, oh, it seems like my dinner's ready. Wonderful. If the second derivative changes signs, I have a point of inflection at x equals c. If the second derivative doesn't change signs at a place where the second derivative is 0 or is undefined, nothing special is going to happen. Take a moment and make sure you get that copy down. And in the next video, I'm just going to show you some examples of this, and we're going to see our analysis. The next couple of examples will look very similar to our analysis of the increasing, decreasing stuff.